Good afternoon. I hope you guys are ready to talk about the mathematical theory of communications. This presentation is brought to you by Radel Hodge, Dina Abraham, and Mike Hemmingson. So Charles Shannon was the one who created this theory. He was born in April 1916 in Michigan. He first founded both the digital computer and digital circuit design theory in 1937. But this theory, the mathematical one, is a theory that he used to prove Boolean algebra could construct and resolve logical and numerical relationships. What is Boolean algebra? Boolean algebra deals with two-valued true or false, or 1 and 0 variables, and functions to find its use in modern digital computers and today to use two-level systems called binary systems. So he founded the mathematical communication theory during 1945, during the midst of World War II. So that being said, please remember the type of technology that they were using back then. They were mainly using PPMs and PCMs. This was essentially to write. This essentially was written to make transactions between the two information systems much more secure. So this was the diagram that Shannon created. You have information source, and that leads the message to the transmitter. Transmitter sends a signal to the receiver to the destination, and of course you have noise that interrupts the message. So an information source, that produces the message, and that's element number one. The transmitter that operates on the message to create the signal which can be sent through the channel. So a channel, which is the medium over which the signal carrying the information that composes the message is sent. A receiver, which transforms the signal back into the message intended for delivery. A destination which can be a person or a machine for who the message is actually intended. His theory developed the term bit to be used as a term, and as well as the awareness of information redundancy and entropy. What is redundancy? Redundancy is the number of bits used to transmit a message minus the number of bits in the actual information. Therefore, it is the wasted space. A lot of databases actually experience data redundancy because of the lack of maintenance done on their databases. Information entropy. It quantifies the expected value of the information contained in the message, and usually in units such as bits. In this context, a message is a specific realization of random variables. So what was the need for this theory? Shannon believed the fundamental problem of communication is reproducing at one point either exactly or approximately a message selected at another point. Therefore, there could not be one meaning to a specific code. There could always be more. This was one of his formulas. So the three main reasons he actually created this theory were because parameters of engineering importance, such as time, bandwidth, number of relays, tend to vary with the number of possibilities. So the second reason was to measure the entities by linear comparison with common standards. So, for example, he believed that 2 punch cards should hold twice the capacity of 1 for information storage. It was mathematically suitable. Many are limiting operations, and they're simple and require a lot of work to actually come up with the other number of possibilities. So let's explain the communication diagram. So the information source. It produces a message or a sequence of messages to be communicated to the receiving terminal. Various types. There are various types. A single function of time, as in radio or telephone variable of time, such as television. So think about when you actually send out a text message. A transmitter, it operates on the message in some way to produce a signal suitable for transmission over the channel. A channel, the medium used to transmit the signal from transmitter to receiver. A receiver ordinarily performs the inverse operation of that done by the transmitter, so it's reconstructing the message from the signal. So who's the destination? The destination could be the person or the thing the message is intended for. So in this case, it was two machines actually talking to each other in the time that this was developed. So Shannon actually identified 3 types of communication systems, so we'll go ahead and identify those. The first one is discrete. It is one in which both the message and the signal are a sequence of discrete symbols. Type number 2 is a continuous system, which is one signal or a message are treated as continuous functions. Mixed systems, both discrete and continuous variables appear in the PCM transmission. So let's explain all 3 in a bit of detail. So discrete, it's a noiseless channel. So the teletype and telegraphy are 2 simple examples of a discrete channel for transmitting information. Generally, a discrete channel will mean a system where a sequence of choices from a finite set of elementary symbols. For example, dots, dashes, numbers, etc. So what kind of discrete source of information, what kind of question would be asked? Is how is an information source best described mathematically, and how much information in bits per second is produced in a given source. So there's a series of approximations to translate these into English. So there is 0 order, 1st order approximation, 2nd order approximation, 3rd order approximation, 1st order word approximation, and 2nd order word. There's also graphical representation of Markov process. And there are mixed resources or sources. Then choice, uncertainty, and entropy. And the entropy of an information source. Representation of the encoding and decoding operations. The fundamentals theorem for noiseless channel, finding the inefficiency in coding. And now to go to the discrete channel with noise, so in case there is any interruptions. And this is how the graph would look for that. So now let's talk about the continuous system. The continuous channel, the input or transmitted signals will be continuous functions of time, belonging to certain set, and the output or received signals will be versions of these. We will consider only the case where both transmitted and received signals are limited to a certain band, and they can also be specified. So the rate of transmission of information for a continuous channel is defined in a way to that for a discrete channel. So I hope this covers the mathematical theory of Shannon's. Unfortunately, there is a lot of information in this, and I hope this was a brief but clear description of exactly what the theory of communication dealt with and how complex it is. And I appreciate you guys listening and watching this lecture. Thank you.